Hello guys, welcome back to my YouTube channel. Today I am going to solve day 20 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today I am going to solve problem number 1552, magnetic force between two balls. Okay, so let's read the problem statement first. So, in the universe Earth C137, Rick discovered a special form of magnetic force between two balls if they are put in his new invented basket. Rick has n empty baskets. Okay, the ith basket is at position I. Okay, so see, this is a position array given to us, right? So this basket is at position 1. This basket is at position 2, this basket is at position 3, this basket is at position 4, and this basket is at position 7. Okay, so Rick has n empty baskets. The ith basket is at the position I, and Morty has m balls. Okay, Morty has m balls and needs to distribute the balls into the baskets such that the minimum magnetic force between two balls is maximum. Okay, such that the minimum magnetic force between any two balls is maximum. So Rick stated that the magnetic force between two different balls at position x and y is nothing but the absolute of x minus y. So we have given an integer array position and the integer m, and we have to return the required force. Okay, so now let's understand the problem with this example one. Okay, so here this is a position array given to us and m is equal to 3. That simply means that we have 3 balls. Okay, so we have to distribute the 3 balls into the baskets, right? So first ball, let's say if I placed this ball here. Okay, first ball I have placed here, and the next ball I have placed here, and third ball I have placed here. So in this case, you see that the force between all the balls is 3, right? All the balls is 3. Okay, and this is the force that we can get, right? So we have to distribute the 3 balls into the baskets 1, 4 and 7. Will make the magnetic force between ball pairs 3, 3, 6, right? The minimum magnetic force is 3. We cannot achieve a larger minimum magnetic force than 3. Okay, so here see, if I placed, let's suppose if I place one ball here and next ball here and then next ball here. So see here, then the minimum magnetic force here is coming as 2 now. We have to make it as maximum as possible, right? So this is the only possible way. Okay, I have to place the 3 balls. Okay, if I place just one ball here, just one ball here, then after that my best solution is going to be to place this ball somewhere here in between. Okay, in between my low and high. Okay, so in the mid I have to place. Okay, so definitely you guys are knowing that where we are heading now in this problem. Okay, so we are heading to binary search, right? So first thing that we have to do in this problem is to become a greedy. Okay, we have to sorted this position array. Okay, so first thing is that we need to do is the sorting of this position array. Okay, so let's say if I have 2 balls, then definitely I want to place my first ball at this position and the next ball is at the maximum position. Okay, so in this way only we can get the minimum magnetic force. Okay, when the balls is at larger distance. Okay, okay, so from here one thing is clear, that we have to implement a binary search. Okay, we have to become greedy. That is why we have to sort our array, right? So after sorting this array, now let's see how we are going to implement the binary search here. Okay, so first thing that we need to understand here, that if I have 2 balls now, if I have 2 balls, so this is the maximum distance that I can get. Okay, so this is the maximum distance, right? So let's name this maximum distance that I can get is right. Okay, this is going to be my right. Okay, and minimum distance that I can get, minimum distance that I can get if I want to just place 2 balls. Okay, so minimum distance I can get is 1, right? So let's name it as my left. Okay, so initially what I'm saying, initially my left value is going to be 1 and my right value that I want to give is nothing but is this max position. Okay, what is this max position? 7 minus this value. Okay, 7 minus 1. So this is the max distance. Okay, so my left is going to start from 1 and my right is going to be 6. Okay, so here why I'm saying that I'm always comparing two balls. If there is just one ball, then what we need to do? So actually in problem statement it is given that m is always greater than 2, right? M is equal to 2 or greater than 2. Okay, so this is going to be my left and this is going to be my right. Okay, so left is the minimum force. Okay, left is the place where we can get the maximum force, right? Maximum force, because two balls are very near to each other. And right is the place where we are going to get the minimum magnetic force, because balls are at very much large distance, right? So now after that, inside this, after that we have to just run one while loop. Okay, we have to run one while loop while my left is less than equal to my right. Okay, and inside that I have to find first min or mid. Okay, so how we are going to find the mid in binary search? Okay, simple formula. Mid is nothing but my left value plus right minus left divided by 2. Okay, this is how we are going to calculate the mid, right? And after that, after finding the mid, we have to call one method. Okay, and that method is going to give me true or false. Okay, if we can place the balls or if we can't place the balls, like this. Okay, so mid is going to be nothing but the minimum force. Okay, mid is going to be nothing but the minimum force. Okay, so initially, let's say in this particular example, my left is 1, my right is 6, right? Left is 1 and right is 6, and what is the value of m? M value is 3, right? So I have to place total 3 balls, right? So what is going to be my mid? Okay, so here when I'm going to calculate the mid, it is going to be 1 plus my right is 6. Okay, 6 minus 1, 5 divided by 2. So it is going to be give me 1 plus 2 is equal to 3. Okay, 3 is going to be my mid. Okay, then after that, what we have to do? Now we know that our mid is 3. Okay, so now this is my array, 1 2 3 4 7. Okay, so initially my first ball that I need to place should be here. Now I need to start from here. Okay, I need to keep my first ball in the starting position only. Okay, so this is my array, right? 1 2 3 4 7. Okay, so now this is fixed. Okay, I have to place my first ball in the starting position only. Okay, this is fixed. Okay, now after that, now my mid is 3, right? So now after that, what I have to do? I have to check this value. Okay, what is this value? 2 minus my last position is this. Okay, my last position is this. 2 minus 1 is greater than equal to my mid is nothing but, let's say, min force. Okay, this is the minimum force that I have to maintain right now. So 2 minus 1 is greater than equal to 3. 1 is greater than equal to 3. No, it is not false. So definitely I'm not going to place my ball here. Okay, then I reach here. So 3 minus 1 is greater than equal to my min force, 3. Okay, so 2 is greater than equal to 3. No, so I'm not going to place my ball here. Okay, now after that I reach here. 4 minus 1 is greater than equal to 3. Yes, this is true, right? 3 is equal to 3, right? So I can place my ball here. Okay, so I have placed my ball here. Okay, this is done. Then after that I reach here. So here what I need to do? Now this is going to be my last position. Okay, so initially this was my last position. That is why I'm 2 minus 1, 3 minus 1 and 4 minus 1. Now this will become my last position. Okay, so here 7 minus 4 is greater than equal to this 3. 3 is nothing but my mid, or we can say my minimum force. Okay, so yes, this is also true. So I can place my ball here. Okay, so I have placed my ball 1 here, ball 2 here, and bolt 3 here. Okay, so right now see here, side by side I am going to increment the count. Okay, how many balls I have placed till now. So I have placed 3 balls till now, and my count will become equal to m. Okay, m value is nothing but 3, right? M value is nothing but 3. So if my count becomes equal to my mid, okay, becomes equal to my number of balls. Okay, count becomes equal to m, then in that case I have to simply return true. Okay, I have to return true here. Okay, okay, I can place all the balls right now, right? So now after this, if I am able to place all the balls, okay, now I am running this while loop now. Inside this while loop I find this mid is going to be nothing but my minimum magnetic force. Okay, minimum force. Then after that I have to call one method. Okay, I have to call one method if I can place the balls. If can place the balls. Okay, if I can place the balls. Okay, so here right now I am returning true, right? I can place the balls. So now here inside that, let's create one variable best. Okay, in best I have to store the best answer. Okay, so initially my best is equal to 0. So now I have to store my best answer as 3. Okay, best answer is equal to 3 here. Okay, best is equal to mid. I can simply say best is equal to mid. Okay, then after that I have to update my left as mid plus 1. Okay, I can place the balls at this mid distance. Okay, at this distance I can place the balls at this much distance. Okay, let's say this distance is 3. Okay, so this is my left, this is my mid, and this is my right. Okay, so this is the best answer that I have get till now, right? So now let's suppose that I move my left to mid plus 1. Okay, I move my left to mid plus 1. Okay, so now my left is going to become mid plus 1. Okay, so left is nothing but the minimum distance, right? Left is nothing but the minimum distance. Okay, so see here I have explained left is nothing but the minimum distance when I place the balls. Okay, side by side. Right now we know that right now we know that this is my best answer. Okay, until here. Okay, so now let's check for other possibilities now. Let's check for this much possibility. Okay, let's check for this much of possibility. Okay, this is the minimum distance. Okay, let's say. So now my left is going to become mid plus 1. Left is going to become mid plus 1, and okay, so now again I have to do the binary search. Okay, so left is equal to mid plus 1, so my left will become mid is equal to 3 plus 1 4. Okay, left become 4. Okay, left become 4. So here again I have to check if 4 is less than equal to right. So 4 value is less than equal to right 6. Yes, 4 is less than equal to 6. Okay, so again I have to find the mid. Okay, so again I have to find the mid, and mid is going to be left plus right minus left divided by 2, and mid is equal to left is 4, right is 6 minus 4 2 divided by 2 is equal to 4 plus 1 is equal to 5. Okay, this is going to be my mid. Okay, so now let's try this possibility. Okay, let's try this possibility. So this is my array, right? 1 2 3 4 7, right? So let's say first I have placed my ball here. Okay, this is fixed. I have placed my ball here. After that, can I place my ball here? So 2 minus 1 is greater than equal to 5. No. Can I place my ball here? No. Can I place my ball here? 4 minus 1 greater than equal to 5. No, because minimum force is greater than right. 3 is, this is false. Okay, so can I place my ball here? Yes, I can place my ball here, because 7 minus 1 is greater than equal to my this minimum force. 6 is greater than equal to 5. Okay, I can place ball here. So only 2 balls I am placing here, right? Only 2 balls, max 2 balls I can place if I maintain this as my minimum force. Okay, 5 as minimum force. Okay, so now we can't place total 3 balls. Okay, so definitely this function is going to return me false. Okay, if can place false. Okay, so now in the else part, what I have to do, in the else part I have to just move my right to mid minus 1. Okay, so now let's search for other values. Okay, mid minus 1. Okay, so my left was 4. Okay, in the last case my left was 4 and my right was 6. Now right was 6 previously. Now it is going to become mid minus 1. So what was my mid? Mid was 5 minus 1 is 4. Okay, right becomes 4. Okay, right is mid minus 1. Okay, mid minus 1. Okay, this is what we need to apply here. Okay, if I can place both, then my best is going to become mid and left is going to mid plus 1, and in the else part, if I can't place the both, then my right is going to become mid minus 1. Okay, so now again we have to apply the formula. Okay, mid is equal to left is nothing but 4. Okay, and my right, this time my right is 4 minus 4, 4 minus 4 divided by 2, 4. Okay, this is going to become 4. Okay, right now see, can we place the balls? Okay, so 1 2 3 4 7 is the array. 1 2 3 4 7 is the array, right? This is fixed. I have placed one ball here. Then 2 minus 2 is 2 minus 1 is greater than equal to m. No, here I can't place ball. Okay, minimum force I need 4 now. Here also I can't place the ball. Here only I can place the balls. Okay, again only 2 places. So again my right is going to decrement it. Okay, so now my right is going to become again mid minus 1. Okay, mid minus 1. So now my right will become 3. Okay, now I can't execute this. Okay, while my left is 4 and 4 is less than equal to, right? So this condition becomes false, right? So now I have to just return the last stored value of this best. So what was the last stored value of this best? Is nothing but the 3. Okay, here we are going to place all the 3 balls, right, perfectly. So that is why my best was 3. Okay, so here in the end I have to just return the 3. Okay, return the 3. Okay, so this is going to be my approach. Okay, so code is going to be very similar to what I have explained now. Okay, so let's do the coding first. Okay, so here arrays dot sort. Okay, this is what we need to do, right? Position. After sorting this, now we have to just do the binary search for the answer. Okay, so left is going to be nothing but the minimum distance. Okay, if I just place the balls together. Okay, so here I am just going to write 1. Okay, initially, and my right is going to be the max distance. So how we are going to get the max distance? So here let's take a variable int n is equal to position dot length. Okay, so here my right is going to be nothing but position of n minus 1. Okay, and minus position of 0. Okay, this is going to be giving me the maximum distance, right? This is done. Then after that, initially let's take my best as 0. Okay, so now we have to run one loop while my left is less than equal to my right. Okay, and then we have to calculate the mid. Int mid is equal to left plus right minus left divided by 2. Okay, after calculating the mid, I have to just call one method. If I can place balls. Okay, and here just pass my position array and how many balls that I need to place m, and what is the minimum force that should be there. So I am writing mid here. Okay, so if I can place the balls, then I have to write my best is equal to mid. Okay, same what I have explained in the code story, and my upper left is going to be updated as mid plus 1. Okay, and in the else part, if I can't do this, then I have to shrink the max distance, right? So right is equal to mid minus 1. Okay, this is done, and in the end here we have to just return the best. Okay, this is done. Now let's define our can place balls method. Okay, so here let's write the method private static boolean can place balls. Just write my position array and write M, and here let's take this mid as min force. Okay, this is going to be my mid force. Okay, so initially as I have told you, we have to place the first ball in the first basket, right? So here initially I'm taking my count as 1. Okay, I have placed my first ball, let's say, in the first basket. Okay, and count is equal to 1, and last position I have to set as position of 0. Okay, simply means that I have placed my first ball in the first basket. Okay, that's it. Okay, now after that we have to run one loop for int I is equal to 1, I is less than position dot length I plus plus. Okay, and here inside this, if this is what we need to check, right? If position of I minus my last position is greater than equal to min force. Okay, if this is true, then only in that case I have to increment the count, right? Only in that case I have to place another ball here, right? So I have incremented the count, and I have to update my last position as well, right? So now my last position is going to become position of I. Okay, this is done. Now after that, if count is equal to M, then we have to return true. Okay, so if my count becomes M, then definitely that means that I can place all the balls. Okay, now in the end, if we have to just return the false. Okay, so now let's run the code and see if there are any code issues. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity is going to be O of n into log n. Okay, so see why time complexity of n log n. So here this is the method, right? Max distance. Okay, in this method we are first sorting the position array. Okay, so here my time complexity is going to be O of n log n. Okay, and after that I am running this binary search now. So for here I can simply say that my time complexity that is it's going to take is O of log n, of log of n. Okay, let's say log n, because we are running from left to right now, right? So this is time complexity, and then after that I am calling this can place balls method. Okay, and this method is running for 1 2. Okay, so here also it is going to take n. Okay, so O of n for this one. Okay, O of n. So in general, overall effective time complexity that I'm going to say is going to be O of n log n for this particular problem. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye.